Good morning, student.
Good morning.
Okay, how are you today?
Great.
Good. Keep your spirits up. Before we start to listen, let's pray first. Let's pray together. Finish. Okay, on this occasion, we will get into the discussion of stress, strain, and Young's modulus. We will to first describe the concept of stress, strain, and Young's modulus. Second, formulate the mathematical equation of stress, strain, and Young's modulus. Third, applying the concept of stress, strain, and Young's modulus in a problem. Fourth, discuss the concept of stress, strain, and Young's modulus. Okay, notice the following phenomenon.
Tenang, ini dia. Waduh!
And this is what happened to catapult rubber. When we pull the thread case on the catapult, the rubber of the catapult will stretch. So, based on the videos, what question come to your mind?
Excuse me, sir. My question is, why is it then when the rubber of a catapult is pulled and then released, the rubber can return to its original state so that it can launch an object? And then, why when the rubber is pulled, there is a shrinkage in the cross-sectional area of the rubber?
Okay, that's a good question. So, let's write down the question first. The question from Badrol is, why is it that when the rubber of a catapult is pulled and then released, the rubber can return to its original state so that it can launch an object? And the second question, why when the rubber is pulled, there is a shrinkage in the cross-sectional area of the rubber? Thank you, Badrul. Give applause. The answer number 1 is the elastic properties or elasticity in the rubber that makes its state can return to its original state after the withdrawal process is complete and then released. And the answer number 2 is the phenomenon of shrinkage in the cross-sectional area of an elastic object when a tensile force is applied to it is the phenomenon of stress on an object. Are you ready?
Yes, we're ready.
Okay, look at the picture. This is an image of a spring being pulled. When we pull a spring, the spring will experience A or B.
B.
B. Yes, it's true. Stress is defined as the quotient between the tensile force experienced by the spring and the cross-sectional area of the spring. So, mathematically it is written stress is equal to A or B. 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 Yes, it's true. In this figure, the tensile force exerted on the spring attempts to stretch the spring until the initial spring length increases by delta L. Strain is defined as the quotient between increased length and initial length. So, mathematically written A or B. A. Yes, it's true. Then, Young modulus is the ratio between stress and strain experienced by the object. Mathematically written right or left? Right. Yes, it's true. Okay, from the equation, when substitute it becomes, use the symbols sigma for stress, E for strain, and E capital for Young's modulus. So, mathematically written right or left? Right. Yes, it's true. Amazing. Applause for us. So, we have learned about stress, strain, and Young's modulus and their mathematical equation. And here is one problem. Please do it, and it will be discussed at the next meeting. Keep up the spirit of learning. Hopefully it will be useful. See you. Nice to meet you.
Nice to meet you too.